Alright, for this one, we're going to do the law of cosines now. We just did law of sines in the first part of the video. So here, we want to solve triangle ABC. We have little a, so side A is 12 feet, side B is 15 feet, and side C is 13 feet. So this one, I didn't include the picture of the triangle. If it helps, you can certainly draw one out. Like I said, A, B, and C here are the sides of the triangle, and we need to figure out what the angle measurements are. So to start out with, I'm going to use this version of the law of cosines that I have in the parentheses here, which once again you will need to know for whenever you're doing the homework and such. So here in this case, we want to plug it in just as I have in the formula here. So we would have 12 squared, a squared, equals, and then we have b squared, which is 15 squared, plus the c squared, which is 13 squared, minus 2 times 15 times the 13, and then times our cosine of angle A, hence why it is a capital A there instead of lowercase. So remember, once again, capital letters represent the angle measurements, lowercase letters represent the sides. So next step would be to square those values. We need to try and simplify what we can here. So I got 144 equals 225 plus 169 minus, and then we want to multiply together our 2 times 15 times 13 there. If we do that, we get 390 times cosine of A. Make sure anytime you're doing calculations, you are using your order of operations. So keep in mind, since this 390 has the cosine of A being multiplied by, you cannot combine it together with this 225 and the 169. So our next step, we can only add those two parts together. You can't add or subtract rather the 390 from it because it's being multiplied by cosine of A. They are not like terms. So for your next step here, you'd have the 144 is equal to 394 minus that 390 times the cosine of A, and then we need to try and get that part by itself, so we need to subtract the 394 from both sides of the equation. So then you should have negative 250 is equal to, and then on the right hand side, we just have that negative 390 cosine of A left. And then just like whenever you're solving for variables before, we need to divide by the part in front of our variable. So divide by the negative 390 to get the cosine part by itself. For right now, I'm going to keep it like that as a fraction, so it's exact. You could definitely simplify that fraction first if you wanted to. I just want to show that you still have that fraction there, really, and you have that cosine of A. So to get just A instead of cosine of A, we need to use the inverse cosine function. So that's your cosine to the negative 1 is how it looks on your calculator. Cosine to the negative 1 power is what it looks like, and you would want to make sure to put that in parentheses, because then this inverse cosine and the regular cosine cancel out. So then here you should get about 50.13 degrees for your angle A. Of course, depending on the problem, will depend on how you may need to round your answer. So make sure to read the directions, see if it specifies what to round your answer to. Once you have one of the angles, then you can use law of sines again. So remember, the reason we couldn't use law of sines here is because we only knew 3 of the sides. We didn't know any of the angles. And if we scroll back up here to that law of sines, remember the law of sines, you really have a side over sine of that opposite angle. So you have to have at least 2 sides and an angle, or 2 angles and a side, which we do not have for number 2 to begin with. So that's why we had to start out with the law of cosines here. But now that we have one of those angles, we can go back to that law of sines. So here, for instance, we could do 12, which was our side A, over sine of that angle A that we just found, which is sine of 50.13, is equal to, and then we could do side B, which is 15, over sine of angle B to figure out what angle B would be equal to. And then just like we did in number 1 for the law of sines, we can cross multiply. So here we would have then the 12 times sine of B is equal to 15 times the sine of 50.13, and then divide both sides by 12. This time you're not doing it by the sine function because the sine function is attached with the angle B. So we will have to do an extra step that we didn't have to do for number 1. We are then going to have to do the inverse sine. So remember, the inverse is that to the -1 power of your sine of B is equal to, and then you also have to do inverse sine of what you have right here. So if you calculate that part, you get about 0.959376, and then some other numbers there. You want to make sure to include all the digits that you have there whenever you're plugging it in here, so that way it's not rounded until the very last step. So then for your angle B, you should get 73.61 degrees. And make sure that you are always including your units anytime you have units involved. So remember, that was because the inverse sine and sine canceled out. So the inverse sine of that 0.959376 gives you 73.61 for angle B. And then remember, once you have 2 of the angles, to get the third angle, you can subtract them from 180 degrees. So you'd have 180 minus that 73.61 that we got for angle B, and also subtract off the 50.13 that we got for angle A. So then for angle C, looks like we get about 56.26 degrees, and that'd be for angle C here. So remember, you want to make sure that you are double checking, make sure with your calculator you're getting these same answers, otherwise you might be in the wrong mode. You might be in radians rather than degrees. Always needs to be in terms of degrees. If you do have questions, make sure to ask like normal.